One important thing when talking about the graphs of quadratics, the parabolas that we've been looking at, is we need to know the range and the domain. So your goal for today is I can identify the domain and the range of a quadratic. So it's been a while since you looked at domain and range. Let's quickly define them. A domain is all the possible x values. It's all the values that go into a function. It's an input. The range is all the possible y values, all the values that come out of a function. So when you put a number into a function, some math happens to it, and then a new number comes out. This is actually pretty much the exact same as a snack vending machine. So if you think about a vending machine like this, right, you put in like $1, and then you hit a button like B2. So that number that you press, that combination that you press would be the domain. That's the input. All the possible ones of those, A1, A2, A3, B1, B2, B3, all that stuff, that's all the domain. The range would represent all the snacks that could put into that machine. So everything that could come out of that machine. Here we have Doritos, we have Lay's, we have barbecue Lay's, we have Fritos. I don't know what these two things are. We have raisins, we have Cheetos, Snickers, Milky Ways, Three Musketeers, Skittles, M&Ms, all Twix, all that stuff. All of those represent the range because they're all the things that could come out of the function, right? So a vending machine is just like a quadratic function. So how does this relate to a function? How do we actually take this concept and use it in a graph sense? So here is a graph. It's of 1/2 x squared minus 2. Try to use the simple function, one that you wouldn't really see too often, but something that I think visually makes sense. So we want to know what are all the possible inputs. So when I think of this function, the thing that you put in, that you substitute in, is this x value. So the x values are what gets put in. The y value is what comes out after you square the x value, multiply it by 1/2, and then subtract 2. So in order to figure out all the possible x values, let's ask ourselves two questions. How far left does the graph go? And then how far right does the graph go? So looking at this x-axis, this horizontal axis right here, I want to know how far left does it go and how far right does it go? And the key thing to look at are these arrows up here, this one and this one. If you notice, it's not a straight up and down arrow, right? It's slightly slanted, meaning that it's going left. It's just doing so at a very, very slow speed. If I were to draw it in a more abrupt, in a faster way, it would go like this, right? Which means that the x values, we start at 0, we have a value here, -1, we have a value here. Right, so here are our values. You got 0, -1, -2, -3, -4. It's going to keep going. Is it going to stop? Hell no. This is what the arrows mean, right? It's going to keep going on forever to the left. So how would I represent that? Well, remember, these are the negative values. So going on forever in the negative direction, that'll take you to -infinity. And the same thing is going to be basically true on the right. If I look at all the values from 0 on, we have a value at 1, we have a value at 2, we have a value at 3, we have a value at 4. It's going to keep going further to the right. It's going to keep giving us parts of the function from inputting values, right? If I were to find x equals 6, I could do that. X equals 10, I could do that. X equals 100, I could do that. And it's just going to keep going and going and going. So the furthest right it's going to go is all the way to +infinity. It is just going to keep on trucking. So that's how the questions that we have to ask ourselves for the domain. And I'll show you how to write the domain in a quick second here. So for the range, we have to do all the possible y values, which instead of left or right, we're dealing with now up or down. So how far down does the graph go and how far up does the graph go? So we're going to be looking at this vertical axis right here. It keeps jumping. And ask how far low does the graph go, which is all the way down to here, and then how far up does the graph go? Well, hopefully how far up the graph goes makes sense, right? The arrows are pointed up, so they're going to keep on going up forever, right? We have values at 2 here, right? Here's a value at 2, here's values at 4. So it's going to keep going up and up and up. So our lowest value is -2, highest value is infinity. When we write our domain, we write the lowest to the highest, the furthest left to the furthest right, and then for the range, it is the lowest, but I'm going to use the bracket because it's a number here that we want to include, to infinity. That's how we write our domain and range.